Assalamu alaikum warahmatullah. Ni ne Abubakar Abdulhamid. Previous video mun gama da functions, yanzu kuma za mu shiga mu gano limit of wasu functions. Mu ga ake gano limits na functions kala-kala when it approaches infinity, when the limit approaches any number or something like that. So let us say limits of f of x or limit, So let us say we have a function, the function equals to 2x. What is the limit of this function? As x approaches maybe 2, for example. What is the limit of 2x? Idan x is approaching in 2. Kawai ba mu yi direct substitution in the x take, so this limit is 4. Right? Because this is x kuma ta approaching 2. One way kai take limit idan ya existing. So kaga wannan limit din exists. One way kai take limit idan ya existing shine kai taking from the positive direction, from the negative direction idan limits din ya existing. Sometimes ana yin haka kai wannan taking din idan kana da undeterminant form, for example, kana yi substitution sai kaga 0/0. In this case, kai factorization da sauransu. So let us try some example. For example, what is the limit of this function? 1/x minus 2 as x approaches 2. Idan kai direct substitution here, you have 1/0, right? And this thing, it's infinity, probably, yes. It's infinity. So we don't know limits in existing koko be existing ba. Wasu idan at infinity is in existing is close to infinity. Wasu kuma suna cewa be existing ba. So let us see mu gano limits and function din nan from the positive idan you approaching 2, when x approaches 2, from the positive and negative direction. For example, yanzu muna da wannan number line. Here is where x equals to 2. Bari mu test the limits then. Idan x mu ga me function din idan wannan x din ta approaching 2 from this direction, positive direction. Wannan ɗaya yake da lim x approaches 2, say plus nan sama daga sama. That means from the positive direction. Let us test 2.1 tana nan wurin, right? Or let us test 2.2. So we have 2. When we test 2.2 anan muna da 2.2 minus 2. Ɗaya yake da 1/0.2. 1 divided by 0.2 is 20, right? Okay. Idan muka yi testing another number, let us say 2.1. Limits in at 2.1, ɗaya yake da 2.1 minus 2. Ɗaya yake da 1/0.1, right? Ɗaya yake da what? 10. So at 2.0, let me say 2.001, or let me say 2.1. Ɗaya yake da 1/0.01, which is 100. Right? It's 100. At 2.0001, yana ta approaching to me, right? Zaka ga limit thing is what? 1000. So limit thing is getting bigger and bigger when it approaches 2. So we can conclude this limit when it enters 2 then is infinity from the positive direction. So the limit is infinity from the positive direction. So lim as x approaches 2 from the positive direction, the f of x is infinity because mun ga number bigger and bigger take zama. Idan ya zo gab da nan, idan ya rika approaching 2 from the positive. So what about, let us test idan limit din ya approaching 2 from the negative direction, that is kamar 2.9, 2.99999, 2.99, something like that. one is bigger. So look at sorry, from this direction. So let us say 1.9 meters to 1.999, 1.9999. Let us see me yake faruwa. Abin da yake faruwa shine 1 all over x minus 2. Idan muka sa waɗannan numbers din muna da negative answer. Negative, probably negative 0.1, which is what? Negative 10. Idan muka sa 1.99 muna da negative 100. Negative kaza. We can conclude idan limits din ya reaching 2, na f of x zai iya zama what? Negative infinity, saboda number tana girma amma in the opposite direction of x. So the limit as x approaches 2 from the negative direction, na f of x is negative infinity. Cases din da wannan limit din from both direction, limit yana existing idan from both direction are equal. Like from the positive direction equals to maybe 2. From the negative direction, limits are also 2. So limit in ya existing and it is equals to 2. Wannan shine barrier din wannan function. So in this case, negative infinity gare mu da positive infinity. So this limit does not exist. Limit as x approaches 2, no wannan function 1 over x minus 2 does not exist. Okay. And we don't know, so what does not exist, me yake equals to. Let us try to solve problem kamar haka. Let us say muna da limit as x approaches 2, na x minus 2 all over x square, for example, minus 4. Idan muke direct substitution, muna da 0 over 0. In this case, yadda za mu solve problem din tunda 0 over 0. Let us try mu ga akwai factor na sama da za ta iya cancel wannan. Shine first abin da za ka iya yi. So yes, idan muka yi factorizing wannan na ƙasa zai kasance x minus 2 over x plus 2 bracket x minus 2. Wannan factor ɗin. So in this case, wannan zai iya cancel wannan. Alright? Muna da 1 all over x plus 2. So the limit as x approaches 2, 1 all over x plus 2 is something as 1 all over 2 plus 2, and it is equals to 1 all over 4. So this limit exists and it is equals to 1 all over 4. And another problem. Let us find the limit of, for example, limit as x approaches, let's say 2. No function root of x minus 2 all over, let's say, let the limit approach 4, for example. Say me haka. Then common at x minus 4. This, what is the limit of this function? Abin da yake faruwa idan muka yi direct substitution, square root of 4 zai kama 4. 4 minus 2, square root of 4 zai kama 2. 2 minus 2 0. Now kuma zai kama over 0 4 minus 4 because x is equals to 4. So in this case, about the square root and say me conjugation, right? Conjugation shine like x minus 2, x minus 4 multiplied by what? Root of x plus 2 and divide by root of x plus 2. This is conjugation, right? Same you taking limits and after we simplification. So when we multiply this by this, what and then because it come x minus what? Minus 4. And then also come x minus 4 bracket root of x plus 2. When you expand one multiply by this, one multiply by this. So in this case, this can cancel this. So we have 1 all over root of x plus 2. So now we can apply the limit as x approaches to 4 is something as 1 all over root of 4 plus 2, which is something as 1 all over 4 because root of 4 is 2. 2 plus 2, 4. 1 all over 4. So this limit exists and it is equals to it's equals to 1 all over 4. Akwai For example, what about when the limit approach, for example, infinity? Lim x approaches infinity, for example, of 1 over x to the power of 4 plus 5x to the power of 3 divided by 5x to the power of 3 minus 9x squared, for example. What is the limit of this function when it's approaching? In this case, it can apply limit in infinity to the power of 4 is infinity plus infinity. Monad infinity over infinity here. Let us say here is plus. So this function monad infinity over infinity on determinant form. So the best way at approaching on a problem when the limit approaches infinity, say considering highest power and denominator, say dividing function through by 1 power, where value of x may highest power. So here x cubed, let's say the highest power at denominator. So we have to divide everything by limit by x to the power of 4. So the limit as x approaches infinity, x to the power of 4 over x cubed plus 5x cubed over x cubed, everything divided by x cubed, right? X cubed common, choose the highest power in the denominator, right? Plus 9x squared over x cubed, like this. So this can cancel this. Number limit as x goes to infinity, x cubed, so write x there, stem plus 5, and then cancel 5 plus what? 9 over x yet again. When we apply the limit now, infinity plus this is what? Is infinity, right? And all over 5 plus 9 divided by infinity is 0. Anything divided by infinity is 0. So infinity divided by 5 is infinity. So this limit is equals to infinity. It approaches, when x approaches infinity, the limit equals to infinity. So by the barrier. What's nature does not exist. What's nature is also preferably go because I is infinity. Quote is up. Abin da yake faruwa nan shi ne idan muna da another case, dole mutum ya san cewa limit as x goes to 0 na sine x over x is 1. So in this case, limit as x goes to 0 na sine 3x over 3x when x approaches 0 is 1 also, because angles then has to, one angle then has to equals to one denominator. So yeah, that can go no limits when limit as x goes to 0 na sine 5x, for example, over 4. Yeah, that can, or over 3, or over any number. One dollar kai matching into, yeah, that can matching into, it has to be 5. So let us say here we have this, or let us say 4. So yadda za ka yi nan ƙasa sai mun samu 5x don mu maida shi in form of irin wannan. So we can multiply denominator and denominator by 5x. So you have to multiply by 5x and then we can multiply by 5x so that in kai cancelin ba ka ƙara komai ba, balance. So in this case, za ka iya raba limits in as x goes to 0 muna da 5x over what? Over 4 times sine 5x divided by what? 5x. Now when you apply the limit, here is 0. 0 times 1. The limit of this is 1. 0 times 1 is 0. So the limit equals to 0. No. One is in the case of trigonometry. To do like some now cause relationship, no causes, but this is the main idea. So the simple way, idan ka samu 0 over 0, idan ka samu infinity over infinity, and so on, the best way you can find the L'Hopital rules. L'Hopital rules was the rule. Abin da yake faruwa shine in ka samu wannan kai factorizing numerator the denominator, where kai differentiating into. For example, in this case, if f of x equals to x squared minus 4 all over what? X minus 2, for example. In this case, what is the limit of f of x when x equals to 2? What is the limit of f of x? Idan ka sa zaka ga kana da 0 over 0. So in this case, we have to differentiate na sama da na kasa. Derivative of x square zai kasance 2x, derivative of x of 4 zai zama 0, derivative of this is 1. So this limit is same as 0 then now. This is 2. So that means 2 times x. Idan muka apply limits at the end, it will be 4. Another way to do this, kai factorizing na saman, kamar yadda muka yi ɗazu, kai dividing by x minus 2, you can cancel this. Kana da x plus 2. So now apply the limit when as x goes to 2. Kana da 2 plus 2, that is 4. So the limit exists and it is equals to 1 and 4. Alright? So haka wannan fitarwa. In ka samu 0 over 0 za ka iya yin derivative ɗin. Ya za ka yi ka gano 2x ɗin nan shine differentiation. Whatever power ɗin kai multiplying by ita, derivative of this zai kasance kai multiplying by the power n kenan. Then subtract 1 from the power. In this case, power is 2, na yi multiply ya bani 2x, amma na yi subtracting 1 to saura 1. Sai sa muke da 2x to the power 1. Wannan 4 ɗin kuma ɗaya yake da 4x to the power of 0. In kai multiplying by the power 0, negative 1, 0 times anything is 0. Shi yasa derivative of 1 is 4. So anything here. Haka na ƙasan ma. Power ɗaya is 1. 1 times 1, saura 1x to the power of 1 minus 1, 0. Anything to the power of 0 is 1. 1 times 1 is 1. So she need derivative ɗin wannan. So this is it. What about idan muna da irin piecewise wannan? For example, function. Misali muna da f of x is equals to, for some interval just. For example, this is something